In this video, we're going to talk about properties of a rhombus, rectangle, and squares. So first off, I need you to know that for a parallelogram, that a rhombus is going to have all properties of parallelograms. So all the things we talked about in previous videos will still apply here. And first off, all four sides are going to be congruent. So that's shown right here in this first picture. So then, next, in this next picture, you can see that the diagonals are going to be perpendicular to each other. And then in the next picture, you can see that the diagonals are going to be bisecting the opposite angles. And one thing you want to remember is that with our opposite angles to begin with, we know that they are congruent. So if they are now bisected, you can see that all four pieces are going to be the same size, and same thing with the angles is there as well. For a rectangle, we know again that it's going to share all the properties of parallelograms. And specifically, you can see that we have four right angles. You can see that in the picture right there. And then for a rectangle, we already know that the diagonals bisect each other, but one thing that's going to be a little different with the rectangle is that our diagonals are going to start out being congruent to begin with. So you can see that all four of those pieces are going to be the same size, and that's the biggest thing you want to remember. For a square, it still has all the properties of a parallelogram, but it also shares all the properties of rectangles. So all the ones we just talked about, and more specifically, that it has four right angles. That will also share the properties of a rhombus. And the part about a rhombus that we need to be more particular about is the fact that we have four congruent sides. So it's almost a more specific type of rhombus and rectangle. So for the first question, we have to classify if it's a quadrilateral or not. So we have to know what type of quadrilateral it is. So we can see that there are four congruent sides, and that's really all we are given in there. Because of the fact that we are given four congruent sides and that's it, the only thing we can say that it is a rhombus. Because we can see that they're not right angles, so that means it can't be a rectangle or a square. Next, we have to classify the quadrilateral if it has four congruent sides and four congruent angles. So if we have four congruent angles, then they need to be 90 degrees each. And the reason for that is because, remember, all quadrilaterals, the sum of your interior has to be 360 degrees. So if they're all the same, if we divide that by 4, then we get 90 degrees each. So that means that they are all right angles. And if all of them are right angles and they are four congruent sides, then the most specific can be a square. Because it can't be a rectangle because a square, or because a rectangle just has to be opposite sides have to be congruent. And if it's all four sides are congruent, then we know it has to be a square. In this problem, you can see that we need to classify the special quadrilateral. So because it has four congruent sides and four right angles, we know it's going to be a square. All right, so since we know it is a square, we can set the opposite sides equal to each other. So 2x plus 1 needs to equal my 4x minus 7. So when I subtract my 2x over, I end up with 1 equals 2x minus 7. So I can add my 7 over to the left. So I get 2x equals 8. When I divide by 2, I get x equals 4. Then, for the last part, because we know it is a square, and we know that the diagonals are going to bisect those opposite angles, we know that this little angle right here is going to be 45 degrees. So I can just say that 7y plus 3 has to equal 45 degrees, and then I can solve for that. So if I subtract my 3, I end up with 7y equals 42. When I divide that by 7, my y is going to equal 6. In example 3, you can see that the diagonals of the rectangle PQRS intersect at point T. So we know it's a rectangle, and we know that QS, this whole length, is going to be 18. We know rectangles that each of these pieces are going to be bisected, and they're all going to be the same length. So that means that PR is 18 also, and ST is just 9, since it's just one of the pieces. So next, for the angles, we know that each of the angles in the corners are going to be 90 degrees. So if I take 90 minus my 62, I end up with 28. So that's what this little angle is going to be right there. Because it is an isosceles triangle, I know that one will also be 28. So to figure out this missing angle right here, I can take 180 minus my 28 minus my 28, and I end up with, let's see, 124. And that is my angle PTQ. So 124. For angle QPR, we already know that will be the 28 that we first found right up there. And the rhombus question right here for example 4, you can see that I added in the V, Z, and Y. So the other pieces that we need to add into our picture are the different measurements they give us. So angle XZY is 34 degrees. So from that, we know that since it's a rhombus, I know that these opposite angles will also be 34, because a rhombus will bisect those opposite angles. And we also know, since it's a rhombus, that the angles in the center there are going to be 90 degrees, so they're all perpendicular. With the 7 that they are giving us, we know that the diagonal is bisecting each other, so that the other length is also going to be 7. So that means that WY is going to be 14. That's probably the fastest one to fill out. Another measurement we already have is our next measure is the angle. So angle WZV is right there, that 34 degrees. And XYZ, so XYZ is that whole measurement right there. So one thing you have to remember is that we have supplemental angles. So this is really 68 right there. And this angle, if I take 180 minus the 68, that'll give me that missing measurement. And that is, let's see, 112. So if I divide that evenly, that means that each of these are 56 degrees. I could also use the idea that this is a right triangle, and I know it's 90 degrees, so I could take 180 minus 34 minus the 90, and I'm left with my 56 also. So the last one to do is probably the trickiest one. That's why I saved that one for last. So we need to find XY over here. I'm going to put it as an X. So I'm going to trace out this one in yellow. So this, I'm going to make that in red instead. So that red triangle is a right angle. I have 56 degrees in the corner. My 7 is down there, and I need to find this missing side. So if you notice that this is adjacent, this is hypotenuse, so we need to use the cosine measurement. So cosine of 56 is adjacent over hypotenuse. So when I cross multiply to solve that for my x, I'm going to have to take my 7 divided by the cosine of 56. When I do that, I get 12.5. So that one's just the trickiest one, just because you do need to use your trig from the previous unit to answer that one. For the next question, since it is a rectangle, we know that the diagonals are going to be congruent to each other, and they are bisecting. This means that all 4 of these pieces will be congruent to each other. So when they gave us that the negative 8k plus 26 is right here, and the 4k plus 62 is this piece, we can set them equal to each other. So 4k plus 62 is going to be equal to my negative 8k plus 26. When I solve that, I'm going to move my negative 8k over to get rid of the negative, so I end up with a 12k plus 62 equals 26. So when I subtract my 62 over, I end up with 12k equals negative 36, which is okay. So when I divide, when I divide by my 12, I end up with k equals negative 3, which is all right. But remember, we're finding what the AC is. So what I need to do is I need to take this and I need to put it back into this piece right here. So it's my 8k minus plus 26. And then I need to double it because I have to, sorry, let me plug this in. Because we want the whole entire measurement, we know that they need to be the same size. So I get a 24 plus 26, so that gives me a 50 for one of those little pieces, but I know that they have to be the same size, so I'm just going to double it, so I know that in the end AC is going to equal 100.